The Battlefield Augmented Reality System, or BARS, is a 6.2 research project at the Naval Research Laboratory in Washington, D.C. Its main purpose is to develop a proof-of-concept level system for improving situational awareness of individual warfighters and their commanders. BARS consists of augmented reality backpacks, virtual reality base stations, and the infrastructure to tie them together. Before going further, augmented reality will be defined. An augmented reality system allows its user to operate in the real world and simultaneously see and hear computer-generated cues that appear to exist in the real world. In this example, the computer-generated route appears to exist in the real world, even though it does not. It is like a personal head-up display. The heart of the BARS system is the BARS Backpack, a mobile augmented reality system. This system uses commercial off-the-shelf components to provide augmented reality in a portable and untethered package. On the back is the wearable computer to process information and generate the display, wireless networking hardware to communicate with other users, a GPS unit for determining the user's location, and batteries to power it all. On the helmet is a stereoscopic see-through LCD display, an antenna for the GPS unit, headphones, and an inertial tracker for measuring the user's attitude. The user holds a 3D input device to interact with the system. The effectiveness of augmented reality depends highly upon the quality of registration, which is how well the overlaid graphics line up with the real world. This in turn relies on two factors: quality of tracking and quality of the data to be displayed. Some of the data is stored as 3D models like those used in virtual reality systems. Trackers determine the attitude of the user's view into the real world, and this view is used with the model to project 3D graphics onto the display. If the quality of the tracking is poor or the models are measured incorrectly, the projected graphics will not line up well. This footage shows that the BARS registration is very good given current technology. If there is error in the tracking and we have some estimate of how bad it is, we can use a technique called error bounding. In this case, we change the graphics displayed to indicate the range of where an object can be given the tracking error. One of the most exciting features of BARS is the ability to, in some sense, have X-ray vision. However, being able to see too far will clutter the display and be distracting to the user. For that reason, we have an information filtering system. In this example, the user can adjust the amount of information shown based on distance from his current position by moving a common slider control. Filtering can also be accomplished through semantic information about objects in the database. That will be discussed later. Normally, the BARS displays in the first-person head-up mode. However, an overhead map display mode is available for the user. Centered at the current position, the user may view the map from any angle and distance. Another problem with X-ray vision is knowing how to represent objects that are behind other objects. In the first of many planned user studies, we have started showing subjects different ways of representing those occluded objects and collecting the results. In this footage, the real-world building blocks the view of other buildings behind it as seen on this overhead view. The augmentation shows those buildings using several different rendering techniques. BARS uses wireless networking to distribute information between users. Every user shares the same replicated database updated in real time. In this footage, you can see that one user sees another user augmented by a blue box. In this case, the first user can know the location of the second user even as that user walks behind a wall. Another feature of the system is the ability to create and post reports. Here, the user posts icons that represent possible sniper threats. These reports are immediately distributed to other users on the network. These reports can also be removed or deleted. One important piece of the BARS system is the model of the environment. These models can be constructed in various ways, and other researchers are creating automated systems to do so. However, usually these models are constructed offline, then loaded into BARS at startup time. One feature of BARS to help with modeling is a mode to construct new model objects or change existing ones using the AR system itself. Due to the flexibility and
Hardwire.
adaptability of the BARS data distribution system, we can connect it to other systems. In this example, a user creates a
Minefield.
report of possible hazards on a third-party 2D multimodal system and sees these hazards in the BARS heads-up display. As mentioned earlier, although the BARS mobile AR backpack is the heart of the system, it is but one part. We believe that while the AR backpack will be useful in the field, base commanders will find virtual reality applications useful in coordinating the backpack users. In this example, the VR workbench is used to create a route around a hazard. The backpack user sees this route in the display. However, this display is very confusing because of all the clutter. Everything is shown. And if the user filters simply by distance, some of the route itself is cut off. But using semantic filtering, the system only shows the route and the hazards. As the backpack users follow this route, a user in our immersive VR room can fly through a model of the environment and see the route as well as the positions of the backpack users updated in real time. Work under the BARS project has been featured in several prominent media outlets, including CNN, The Learning Channel, Scientific American, Popular Science, and the New York Times. BARS has been demonstrated at many venues including SIGGRAPH 2001 and the National Air and Space Museum. BARS has also produced 20 journal publications. BARS research is performed in Code 5580 at the Naval Research Lab in Washington, D.C. BARS is funded by the Office of Naval Research.